All right, hello again. This is Jeff Scott of Blackhawk Technical College, and I'll be coming at you right now with the PowerPoint presentation for Chapter 13 for our Advanced Java course, and that is on applets and more. So I think it's Chapter 13. I'm not sure. Yeah, yes it is. Okay, so let's get started on it. Again, I'm going to go over this, and when I get done going over the slides, I'm going to go over the material that's in the chapter. The book that I have is the older book, so the page numbers will not line up. I think hopefully you're used to that by now. So, first we have an introduction to applets. I'm not going to go over the brief introduction to HTML. You all know HTML already. We'll get into creating applets with Swing, using AWT, which is the Advanced Window Toolkit for portability. Talk about how to draw shapes, how to handle different mouse events, timer objects, and finally playing audio. All right. Every program we've done in the course up till this point, up till this chapter, so the first 12 chapters of the book, what we've created are Java applications. And as mentioned there, an application is a standalone program that runs on the computer. For this chapter, and this chapter only, we will create applets. And applets, as mentioned there, are programs that normally run inside of a browser. So as mentioned on the bottom here, if the user opens the website with a Java-enabled browser, the applet is executed inside of the browser window. Now, I'm not going to say that applets aren't used a lot anymore, but it used to be that virtually every single program that you wrote, every game that was out there that you ran under the internet was a Java applet. Not so much anymore, although many still are. All right. Notice it appears to the user that the applet is part of the website, and that's fine. Okay. The applet is stored on the web server. It's associated with a viewed web page, and you don't have to worry about this stuff as an end user because it's just something that at least ideally will be very natural. Once the applet is transmitted, the user's system will execute it, and applets can be used to extend the capabilities of a web page. All right, so web pages are normally written in HTML. We all know what HTML is. Again, unlike HTML, which is static, applets are dynamic. Notice an applet does not have to be on a web server in order to be executed. You can store it on a local computer. You can store an applet on a flash drive and run it from there. Now, a couple things that you can't do with applets. As it says, since they can run on the user system and not on the server, for security purposes, they cannot access the local computer file system. When Java was first introduced as a language, it had a lot of security holes in it, and applets were one of the worst. What happened was it was not illegal when applets were first introduced for a person to go and write an applet that would go out and look at all of the files on a user's hard drive, for example. Not necessarily their hard drive. So if they could look at them, they could also go in there and modify them, remove them, or whatever. So the decision was made fairly early into the history of Java that users were going to be put into what was called a sandbox. So in other words, the worst thing you could do would be to read your own stuff, overwrite your own stuff, remove your own stuff, etc. But that wasn't good enough for most users. They didn't want that. So over the years, we went from totally an applets that literally had no trust to an applet that was only known on the user's machine, and now there's actually something, for several years, there's been something called a trusted applet. And with a trusted applet, it's kind of like creating an applet for a circle of friends, where you can have more power among that circle of friends. But you can see here some of the stuff that by default you're not able to do with an applet. All right. Again, I don't see any reason to go over this introduction to HTML because we already know HTML. To talk about what a basic tag is, etc. Some of the text formatting tags, line break tag, horizontal rule tag, hyperlinks and how to set one up. All right, then let's jump into this. So we're about a third of the way through here, almost. Okay. So creating applets with Swing. As mentioned here, applets are similar to GUI apps, but a couple things that are different. First of all, they don't have a main. Rather, the kind of the equivalent of main is an init. All right, there'll be other methods that you don't see involved in applications that you do have involved in applets. All right. So as it says, instead of displaying in its own window, an applet appears in the browser window. Some of the difference between GUI apps and applet code. A GUI app is derived from JFrame, whereas an applet is derived from JApplet. JApplet, notice by default, is part of javax.swing, so you'll end up importing that in everything that you create as far as applets go. A GUI applet class, a GUI application class has a constructor. An applet class normally does not have a constructor. Again, it has this init method that usually performs the same type of thing as a constructor performs. Notice what you don't have in an applet: a call to super, set size, set default close operation, pack, set visible. As I mentioned, there's no main. The browser creates an instance of the class automatically, and we'll take a look at that shortly. Now, when you run an applet, you typically have pretty much this stuff in there. So you compile the program, and once you compile it, you end up saying code equals the name of your Java program .class rather than .java. Then the width and the height that you see here, that's the width and the height of the applet in the browser window. You need to have those within applet tags, and the applet tag begins here. There's the ending part of the begin tag, and it ends there. You can put a whole bunch more stuff in there, and one of the examples they show in the book, they put a whole bunch of regular HTML in there just so you can see that you can do that. Again, file name.class is the compiled bytecode of the applet, not the .java file. So make sure you get the name .class, not .java. You can specify a path as necessary. If you don't, it's assumed that the file is in the same directory as your HTML is in. Notice the browser loads the specified bytecode, and it executes it in an area, and it creates an applet window the size of width value and height value. Now they talk about Applet Viewer in here, and we're going to have to see how this works because I've had varying degrees of success getting applets to run underneath, Eclipse. So we'll see what has to happen. But let me just give you a very quick little history of Applet Viewer. All right, today virtually anytime you're on a machine, you've got the ability to get onto the internet and do whatever it is you want to do, but that has not always been the case. All right, so what Applet Viewer is it's a program that loads and executes the applet. It executes your applet, but you don't need a web browser. So you don't need to be hooked up to Chrome or IE or Firefox or whatever. You just run it by saying Applet Viewer space followed by the name of your HTML file. All right. Events and applets, as it says, are handled with event listeners just the same way as they are with GUI. We'll look at this one when we go back and look at the book stuff in just a bit. Like I said, the idea here was to just go over these 57 slides. You know, we're almost halfway done here. Notice as it says, AWT is the original library that's been part of Java since its earlier version, but come Java 2, Swing was added. Notice some browsers do not directly support Swing classes and applets, so they require a plugin. So the bottom line is, as with applications, you often end up adding or importing both some java.awt stuff, and some javax.swing stuff. As it says, the AWT classes can be used instead of swing classes if or as necessary. We already talked about these. The name of the AWT classes don't start with J, whereas the ones in the swing class do. All right. Now that's it for now for talking about applets. So let's talk about some of the shapes that you can draw using Java. Now this is important, and this will have a tie-in with the applet stuff, and you'll see what I mean in just a bit. Okay? So components have an associated graphics object that can be used to draw lines and shapes. So you can draw things like rectangles, ovals, which means circles, arcs, etc. Frames or panels can become a canvas for your drawings. The location where you do this stuff, typically you use an X and a Y coordinate, where the upper left-hand corner of your screen is 0, 0, not like we're used to, where it'd be right in the middle. No, 0, 0 is the upper left-hand corner of the drawing area. All right, as it says, the X coordinates increase from left to right, and the Y from top to bottoms. So as you go forward, your X will go like this. As you go forward, your Y will go like this. When drawing a shape or line on a component, you must indicate its position using these X and Y coordinates. This is where it gets to be a little, let's just say, testy. All right? Each component, as it says, has an internal object that's derived from the graphics class. This object has different methods that you can use to draw different shapes. Here's some stuff that you can do. Notice here we're setting the color. So if we say set color, color red, whatever we say is going to, whatever we create will be in red. Get color then would return red. We can draw lines. There's our beginning X and Y coordinate. There's our ending X and Y coordinate. We can draw rectangles. There's our beginning X and Y coordinate along with our width and our height. We can draw ovals. We can draw filled ovals. All right, we can draw rectangles and filled rectangles. We can draw arcs and filled arcs, etc. The other one that you're going to use in here quite a bit is drawstring, because once you start creating your own applet, you might want text to go along with it. So you'll notice that the attributes for drawstring are the actual string itself, and then where on the XY axis it's supposed to begin. In order to call these methods, you need reference to a graphics object. As it says here, one way to do that is to override the paint method. You say, I don't know what paint is. You're going to learn in just a second. You can override paint in JApplet and JFrame and in any AWT class. You can't call paint directly. Paint for an applet means redraw the screen. So if you try calling paint directly, nothing will happen or you'll get an error message. But you can't call paint, but you can call repaint. And repaint kind of, for lack of better words, gives Java a kick in the pants, and it says, hey, call paint when you get a chance. Again, paint is automatically called when the component is first displayed or any time the component needs to be redisplayed or updated. There's the header. Notice it automatically, it must require a graphics object that gets passed in. You don't have to call it G, but G in graphics, that's what people call it. You override the paint method, as it says, it allows you to draw graphics on a graphics object argument. We'll see examples of this in just a few minutes. The graphics object then is responsible for drawing the entire applet window, and you'll do stuff like this. Don't worry about that super.paint. We'll get into all that. As it says, putting all this stuff in there will draw a red diagonal line in the area. Okay? So again, you can draw rectangles or filled rectangles. What's the difference? A rectangle, if you say that your color is green, it'll give you a green rectangle where all the lines will be green, but the inside will be white if it's on a white background like this. If it's a filled rectangle and you do green, the whole thing will be green. Okay? Rectangle takes 4 parameters. the starting point, again, on the coordinate system, x, y, the width of the rectangle, and the height of the rectangle. You could draw ovals, and anything that you draw in here is drawn, even if you don't see it, inside of an invisible rectangle. So as they mention here, when you draw the oval, you're drawing it inside of this invisible rectangle. So again, you need your x, y starting point, your width, and your height. And we'll look at that in just a few minutes. You can work with arcs, and you'll see an example of that in a minute. You can work with polygons. In fact, if you look at this example that's right here looks quite a bit like a stop sign. And that's one of the programs that they will make in just a few minutes will be an actual stop sign. So you can use polygons to draw shapes of different types that don't fit into the standard. They're not squares, they're not rectangles, they're not circles, etc. All right, again, we do not call the components paint method, but we can force the app or applet to call it with the repaint method, as I already mentioned. Sometimes you want to draw on panels, and as mentioned here, if you want to draw on a panel, you get a reference to the panel's graphic objects, and then graphics object, and then you can use that object's method. You're going to see examples of this in just a couple minutes. Again, much of the stuff in here, until you actually see it in action, so to speak, it isn't probably going to make a whole boatload of sense, but it will very shortly, hopefully. And as always, we're going to do an example in class. I'm going to give you an example in class, then you'll have a problem or program to do that really won't be that different than the example that we do in class. All right, mouse events. A mouse generates two types of an event. Two types of events. There are different types of mouse events and different types of mouse motion events. To handle mouse events, you create a mouse listener class or a mouse motion listener class. And again, you will see plenty of examples of this in just a minute. Notice a mouse listener class can respond to a bunch of different events. The mouse button being pressed or released, the mouse button being clicked on, pressed then released without moving the mouse, when you enter a screen space, and when you exit. So we're things like mouse over, mouse out, etc. Anytime you use the mouse listener class, you must implement the mouse listener interface. You're going to see examples of that in just a bit. Here's the different methods that you have available to you. Unfortunately, when you implement the mouse listener interface, you have to include all these. So even if the only thing I want is to put some code into mouse pressed, I still must include mouse clicked, mouse released, mouse entered, and mouse exited. As it says, the mouse event object contains data about the mouse event. Oftentimes you'll call things like getX and getY to find out exactly where you are on the screen, your X and Y coordinate position. Once a mouse listener class is created, it can be registered using the add mouse listener method. A mouse motion listener class can respond to the mouse being dragged or moved, and it must implement the mouse motion listener interface and its methods. And those are shown here. Again, we're going to look at some examples of these in just a couple minutes. The mouse listener class must implement all of those methods. I already mentioned that to you, and you're going to see examples of it in just a couple minutes. Finally, timers. As it says, timers are automatically generated at regular time intervals. All right. So, for instance, let's say that I wanted to write my own screen editor for whatever reason, my own text editor. And I wanted to make sure that every 5 minutes it automatically saved, as an example. I could set a timer event so every 5 minutes it went off, as an example. Again, I think this will make more sense when we actually take a look at it. Here are the different methods that you can use with timers: get and set delays, check to see if a timer is running, starting and stopping a timer. So you can use timer events for a lot of different things. I think with a bouncing ball, it's like if you wanted a new ball to begin every X number of seconds, etc. You'll see that in just a few minutes. The last thing that's discussed in the chapter here, the last 4 or 5 slides, they talk about audio. As mentioned, Java programs can play audio stored in a wide variety of file formats, and even this is kind of old. There's other types of formats that aren't shown here that I believe that Java supports. One way to play an audio file is to use the Applet class's play method. Very simple. So you pass the location or the URL that specifies the location of the file name, and as it says, the sound is played one time. If you don't like it one time, you can put it into a loop. And if you put it into a loop, it'll play continuously. There is a getDocumentBase method, which, as mentioned here, returns a URL object that contains the location of the HTML file that invoked the applet. If the sound specified by the arguments cannot be found, no sound is played. Well, that shouldn't be a surprise. The Applet class's play method, notice that by default it loads the sound file, plays it one time, and then releases it so that the garbage collector can free up that memory. If you need to load a sound to be played multiple times rather than the Applet class's play method, you can use audio clip. And you'll notice right here with audio clip, if you say play, it plays it one time. Loop plays it repeatedly. And stop, typically, maybe you want it to play 100 times or something like that. Then you'd put a stop after the loop. And here is an example of how that can be used. You're going to see that in just a few minutes. Now that's it, and I realize we went over that kind of quickly. The plan is, just so you know, I'm not going to go over Chapter 14 because I already went over using Window Builder with you, and Chapter 14 goes over yet another way that you can draw GUI apps, but we're not going to go through that. I haven't done anything with what's in Chapter 14 in your book. Chapter 15 is on recursion. I will do the same kind of lecturing I'm doing here, in that I will go over the slides and I will go over what's in the book. All right. In fact, just out of curiosity, so this was Chapter 14. It'll open. So creating Java or GUI applications with Java FX. I haven't looked at FX at all. I know nothing about it, so I'm not going to go over it. All right. But I will take a couple of minutes, not today, but I will take a couple of minutes and go over Chapter 15, which is on recursion. And Chapter 15 is a very short chapter. There's only 22 PowerPoints. So we'll go over that, but we're not going to cover any of that in the class. I'm just going to go over it for a completeness type of sake. And then finally, the last chapter that we will go over in class will be Chapter 16, which is on Java and databases. Just so you have some kind of an idea of where we're headed. So we just went over Chapter 13. We won't go over Chapter 14. We'll go over Chapter 15, but just the PowerPoint and what's in the book, where there'll be no homework or anything on it. And we will go over Chapter 16. I hope to have time to create some kind of an app for application for Chapter 16 that we can go over and create as a class. All right. So when we come back in just a minute, I will be going over the material from your book in Chapter 14.